All right, today we're going to talk about exponential modeling problems, and we've already sort of talked about this, but we haven't used logs to solve, and we haven't really talked about this equation right here, which is going to pertain to some interest and compound interest and things like that. So this is what we have looked at. A in this problem is our initial value. And then B is our base, which is 1 plus or minus R, depending. And then we've got X, which is just our exponent. We would use this in two different ways. Number one, when we are given 2 points. And then also when we're given A and R. Okay, so that's our very basic exponential equation. The second one, A of t represents the amount after time. We've got P, which is our initial amount. So it's kind of like the same thing as A, initial value, or initial amount. R is our rate. N is new. N is the number of times it's compounded in a year. And then T is time in years. Okay. So when do we use something like this? Well, we use it when it says the word compounded and then is followed by one of the following: compounded yearly, monthly, weekly, daily, biannually, annually, etc. Okay, then this last one, A of t, still represents the amount after time. P is the initial amount or value. And then E, in this case, is an irrational base of natural log. And that's what we use as our base when we're compounding continuously. R is still your rate, and T is still time in years. So when do we use this? Well, we use this one when it says the word compounded. But then it's followed by continuously. Yeah. Okay. Then down here, so to show you the difference between these, I want you to determine how much money you will have in a savings account if you initially put $1,500 in an account that gives you 4.15% annual interest. And then I want you to compute the yearly, quarterly, monthly, and daily interest you'll receive if you keep the money in the account for 5 years. And then lastly, I want you to determine the amount of money you will have if you compound it continuously. So for all of these first 4 boxes, we're going to be using the same equation. And that equation is going to be that middle equation, the A of t, which is essentially your y, but we just call it fancier, amount after time, is going to be the initial amount times 1 plus r divided by n raised to the nt. Then over here, this one's different. It's going to be that A of t equals PE to the RT. And that's because it says compounded continuously here versus yearly, quarterly, monthly, daily. All right, so what I'm going to do is I'm going to highlight the important information real quick in the problem. So it says that we put $1,500 in. That's my A or my P, okay? So it's your initial amount either way. So it's A in the original and we call it P in the second. So let's just note that those are the same thing, okay? So this is our P. Then we've got 4.15% annual interest here. That is giving me my R, okay? My R is going to be 0.0415 because 4.15% as a decimal is 0.0415. Then it says that I'm keeping it in the account for 5, excuse me, I didn't mean to put a line through that, 5 years. So 5 years, that's my time. T is 5. So I have all the information that I need now to go ahead and plug into each of these different equations. So let's start here with the yearly. So for the yearly, I would say A of T is equal to the $1,500 that I'm initially investing times 1 plus the rate, which is 0.0415, divided by 1 because we're just compounding it once a year, and then it'd be to the to the NT, so 1 times 5. Okay? Quarterly is only going to look slightly different. I'd have 1,500 times 1 plus 0.0415. Quarterly means we are going to be compounding 4 times a year. Okay? And so then that would be raised to the 4 times 5. So remember, yearly N is 1, quarterly N is 4. Then we've got monthly. Monthly would be 12 months in a year. So we'd have A of T equals 1,500 times 1 plus 0.0415 divided by 12 to the 12 times 5. And then daily would be N is 365 because there's 365 days in the year. 1,500 times 1 plus 0.0415 divided by 365 to 365 times 5. Okay? All you have to do from this point is type each of those into your calculator, and that'll give you the amount of money. And I'll write that in just a second. The last one that we want to look at, though, is this compounded continuously. We've got A of T, which is the amount after time, equals that 1,500, which is our initial amount, times the base of E raised to the power of RT, so the rate is 0.0415, times the time, which is 5. Okay, so now all you do is go into your calculator and add this. Let's make a note that the E is on the divide sign. So if you do second E, you should be able to get that, second divide sign, you should be able to get that E. And I do want you using the exact E on the calculator. I don't want you just typing what it's equivalent to. So you would type each of those into the calculator. So for the first one, after you type that in your calculator, you just get A of T equals $1,838, and you're going to round to 18 cents. The next one would be $1,843.92. The next one is going to be $1,845 and 24 cents. You have to round that one up. And then the daily is $1,845 and 87 cents. And the compounded continuously, which should always be your highest, would be $1,845 and 90 cents because you're going to be rounding up. It's 89 or 0.896, so it's going to round up. So that's how you do the compounding continuously. Now let's look at how to solve. So when we take a look at this one, okay, we're not going to do all of these. We're just going to do a few. I'm going to start with the first one. So it wants to know very simply, if you purchase a new car for $20,000 in 1990, the car's depreciating 15% a year, when's it going to be worth $5,000? Okay, so we know that 1990 is x equals 0. I know this is my A or P, whichever way you want to write that. And then 15% a year, that's my R, 0.15. Okay, this is my Y value that I'm solving for. So my function is going to be Y equals 20,000. I'm using the first equation in our chart, times, it's decreasing, so 1 minus 0.15 would be 0.85 to the x power. Okay, now I'm going to set this equal to y, which is $5,000, and I'm actually going to go ahead and solve using logs. So I'm going to divide both sides by 20,000 in order to get the base by itself, which I have 0.85 to the x, and then this is going to be 1/4. Then I'm going to take the log of both sides now that I have the base by itself. So I'm just going to say log of 1/4 equals x log of 0.85. And I know that I can do that because this x is an exponent. I can go ahead and move it to the coefficient of the log expression because it's an exponent of the argument. Then from there, I'm just going to divide both sides by the log of 0.85. And then I will get what x is. So x should be 8.530, so I don't need to put that years. So in 8.53 years, the car will be worth $5,000. All right, let's go to number 3. Suppose you deposited $1,000 in an account that pays 8% annual interest compounded quarterly. How many years would it take to double this amount? So let's highlight our important things. So we've got 1,000, 8% interest annually, compounded quarterly, and then how many years would it take for the amount to double? So let's write some notes. We know that 1,000 is going to be our P. We know that the interest is 8%, so the R is going to be 0.08. We know that it's compounded quarterly, so N is 4. And then double the amount that we started, our Y, we're looking for when Y is 2,000. That's double 1,000. All right, so let's write our function. We've got A of T equals our starting amount, which is 1,000, times 1 plus 0.08 divided by the number of times it's compounded, so N is 4, and then to the 4t. So that's my equation. Now I'm looking for when y is 2,000, so I'm going to actually go ahead and solve. 2,000 equals 1,000 times 1 plus 0.08 divided by 4 to the 4t. Divide both sides by 1,000 first to get the base by itself. That's just going to give me 2 is equal to 1 plus 0.08 divided by 4 to the 4t. Then I'm going to take the log of both sides. Remember that you could use natural log. It really doesn't matter right here. And then because 4t was the exponent, I'm just going to go ahead and move it to the coefficient. Then I divide by the log of the 1 plus 0.08 divided by 4. I literally will just type that in my calculator. I don't really need to do any calculation before the last step, and that leaves me less room for error. So then I've got this. I get what log 2 divided by that is, and that's going to be equal to the 4t that I have left. So I have 4t left right here. 4t is equal to, let me pause and type. So that's about 35.002. And then when I divide both sides by 4, I'm left with t is 8.751 years. So my solution would be 8.751 years. I'm going to set up the last equation, and then I think that you'll be able to solve using logs by yourself. So $4,000 is deposited in something that earns 6.5 annual interest compounded continuously. When will the amount triple? So you would set that up as this is your A or your P value. You have R is 0.065. You have compounded continuously, which means you're going to use E as your base. And then when will that amount triple? So you're looking for when Y is going to be 12,000. So your equation is A of T is equal to the 4,000 that you're starting with times 1 plus, our base is E. So our base is E, and then raised to the RT, so 0.065 T. So that's your equation, and then from there, you set A of T equal to the 12,000, divide by the 4,000, take the log of both sides, and go ahead and solve it. So that is how you solve modeling exponential equations with logs.